Okay, let's move to the second problems on taper bar. The taper bar shown in figure with a uniform thickness of 1 mm and Young's model says E is 200 GPa. Weight density of plate is 76.6 into 10 raised to minus 6 Newton per mm square. In addition to its weight, it is subjected to a point load of 1 kN at its midpoint. So, fine. Model the plate with 2 bar element. Determine the stresses in each element as well as determine the reaction at the fixed support. So this is one of the examination problem. So this is a figure they given. Again, it is a uniform taper bar. It is fixed at one end and other end is free, and it is a height of 240. Total length is, and it is 60 mm, and this width is 30, and here this gap is 15 mm. Either side is 15 mm, 50 mm. At the middle, it is acting the point load 1 kilonewton. So this the load acting at from the fixed point at a distance of 120. That means that it is exactly middle, because 240 minus 120 become 120. So let's solve it. Write the given data. E is equal to 200 GPa. Therefore, the convert into mm square into 10 raised to 3, and weight density again given, that is 76.6 into 10 raised to minus 6 Newton per mm square. See how I said weight density, because based on the unit. Suppose if it is a kg per mm cube, then it is a mass density. Then thickness is given 1 mm and load is 100 Newton. Sorry, 1000 Newton. 1 kiloton is given 1000 Newton. Now, so as I told, here we need to find the mean area. But compared to previous problem, this problem solving to calculate the area is quite different. Why? Because in a previous problem they just given what is the at the top width and bottom width. They are not given this distance. Therefore, we taken directly its average, so 120 divided by 75 divided by 2, like that. But in this case, we should not proceed like that. Why? Because they are given a distance here. This what is the distance gap here they are given. Therefore, we should go for, so we know this gap here, we need to find what is the gap here, then what is the average width here, that we need to find it. So by using a trigonometric approach. So because we know this 15, this is and this one, so here it will form like a triangle. It looks like a triangle. The triangle only have written here in a horizontal way. So this triangle is this length is nothing but 240 and this gap is 15. Now, so there is a form angle that is called alpha, that is taper angle, that is called taper angle. Therefore, we know how this is called a triangle. Let us name it as OAB. So we know this is the adjacent, this is opposite, and this hypotenuse. I know this one is 15, opposite side I know adjacent. So therefore, it is a tan rule we need to apply. Tan alpha is equal to opposite by adjacent, that is 15 by 240. Therefore, alpha become how much? 3.57. So we got an taper angle as either side, it is same 3.57. Now we need to calculate what is the gap or width here. So therefore, that is, let us consider that is as x. Now again we consider one more triangle, O, small a, small b. So consider small OAB, apply tan rule again. So tan rule become tan alpha equal to x by tan alpha is equal to x by, what is the distance here? 120. Up to here the distance is 120. So therefore x by 120. Therefore, what is the x become? 7.5 mm. That means now this gap here 7.5, here 7.5. Therefore, next we are going to write similarly. We need to convert into equivalent stepped bar. This is equivalent stepped bar here now. So we need to calculate this area. So I written a, now first step is to, we need to model FA model. So it is placed vertically. Therefore, we divided into, they are already given in the problem, divided into 2 bar element. If not given also, I told it's look like a stepped bar. How many sections is there? You divided like this much. Now here 2 sections, there were 2 element only. So the node become Q1, Q2, Q3. sorry 1 2 3 and nodal disk q1 q2 q3. Now we need to find the area. So this is one of the important step here, you can observe now. So here this is the taper area, you can observe. So this is a taper. Now this I consider top portion. Now element 1 is this top portion I written. So that top portion here we need to find. I know this x here, therefore if you know x, so what is this middle width become? That is become 60 minus 2 times of x. So that is 7.5 plus 7.5, it is become 7.5 plus 7.5 15. 60 minus 55 45 mm. So this gap is become 45 and height is 120. So this taper bar equivalent to this rectangle. Therefore we need to find, and this rectangular mean width is mean I know height, and we need to find what is the mean width here. So that width we need to calculate. Therefore according to the geometry principle, we know volume of this, assume that this volume of this taper is equal to volume of this rectangle bar, so equivalent bar. Therefore volume of this bar is volume nothing but what, so length into width into thickness here. So that is nothing but width, that is 120, height into 60 plus 45 divided by 2. We are taking a average, keep this in mind, this average width we are taking 120 into 60 plus 45 divided by 2 into thickness is 1 is equal to volume of this equivalent rectangle bar, that is 120 into W1. Therefore W1 into T, again consider T is same. Therefore W1 become how much? 52.5. Therefore area of this section 1 become W1 into T, that is 52.5 mm square. Similarly element area 2, that we need to find this area 2. For this we are taking bottom section now. So now this bottom section of taper equal to this we are taking. So therefore this width is nothing but here how much we find it, same thing 45, and bottom width is 30. So this 45, this is 30, equivalent to this bar is 120, and we need to find W2. So therefore volume of this taper bar become height is 120 into average width, that is 45 plus 30 divided by 2 into thickness is 1 is equal to W2 into height is 120 into thickness is 1. If we solve, W2 become 37.5 mm and A2 become W2 into T, that is 37.5 mm square. So this is only the steps changes compared to the previous problem. Because why we approach, I said, because in this problem particularly they given this gap. In previous problem they are not given, therefore we directly taken average 60 plus 30 divided by 2. If you do it like the same thing you will get, see now, 60 plus 30 90 divided by 2 45. So what we got here, same thing, right? Middle width how much? 45. Again 60 plus 45 divided by 2, that is 105. 60 plus 45 it is 105. 105 divided by 2, it is 52.5. So same thing, but the thing is you should not go with that approach. That is because it's particularly given. We need to find taper angle, we need to calculate what is taper angle, then we need to calculate 6, then we need to calculate what is the middle width, then take both separate sections, equate to volume, then find out the width between the two sections separately, and find out finally area. So rest of the steps are same. So next we need to find stiffness matrix corresponding for element 1 and 2. So this you know well, A1 E1 by L1. This is L1. Substitute corresponding values. Substitute the corresponding values and find out. This is not 100, this is 120. Similarly, K2. So it is become, this value become 0.437 into 10 raised to 5. You multiply by inside, that is become, keep even you can multiply by 2 inside, or you can keep outside. You can do it anyway, you will get the same. So K2 K1, what you are keeping here, K2 also should keep the same. And finally find the global stiffness matrix by adding K1 and K2. This is a global stiffness matrix. We got it. Now this you know how to add it. I already explained the previous video, so that's why we are going directly skipping to the next step. Here one more important step, as like in the previous problem, this is like a self-weight problem. It is subjected to self-weight as well as what you call concentrated load. Self-weight is nothing but body force, so therefore we need to find what is the body force vector as well as point load vector. First we will find that the body force vector in this given bar is placed vertically, so body force acting entire volume due to its weight. Therefore W equal to rho W into V, and also axial load. Therefore for element 1 F1 become rho W. For the F1 belongs to two nodes, therefore we are taking average rho W into V1 divided by 2, rho W into V2 divided by 2. Take common outside, rho W into V1 divided by 2. Now again V1 means A1 into L1. Substitute the values of rho W, A1 and L1, and we got as 0.241. You multiply by inside the matrix, that is 0.241 and 0.241. That is the body force vector for the element 1. Similarly, we need to find for the element 2, that is F2 equal to rho W into V2 divided by 2 1 by 1. So again V2 nothing but A2 into L2. Substitute both the values and solve it, simplify it. We will get 0.1723, multiply by inside the matrix, we got F2. So now there is one more load, axial force, no? Therefore axial force vector we need to find F1, F2, F3. Anyway F1, F3 is 0, F2 is at point is acting 1000. It is acting 1000 Newton. Now finally global vector become F1 plus F2 plus axial, sum of body force plus axial. Add these three. Similarly as like assembly of stiffness matrix, the global force vector become 0.241, 100.413 plus 0.1733. So this one. Now we need to find the global displacement vector, that is Q1, Q2, Q3 unknown. Now finally we substitute in the equilibrium equation, that is KQ is equal to F. Now substitute all the values and apply the boundary condition. Now since node 1 is fixed, Q1 becomes 0, therefore corresponding first row and first column is eliminated in a equilibrium equation. Now rest of things are this much into 2 into 10 raised to 5. Now simplify this. I shown the simplified step for this. You can do it directly in a CALC also. So Q2, Q3 this much, 1.1496 into 10 raised to minus 3 mm. Q2, Q3 is 1.1524 into 10 raised to minus 3 mm. And finally we need to find stress. Sigma 1 is E into epsilon 1. Epsilon means B1 into Q. Again B1 means E1 by L1 in 1 is 1 into 1. Anyway E1 equal to E, both it is made up of only one material, that is 2 into 10 raised to 3 or 2 into 10 raised to 5. Substitute the Q1, Q2 values. Q1 anyway 0, Q2 we got it as 1.14 into 10 raised to minus 3, L1 is 120, therefore sigma 1 become 1.915, that is plus, that is means tensile. Similarly sigma 2 E2 B2 into Q, sigma 2 become 0.005 Newton per meter, that is also a tensile. So both are tensile in nature because it's particularly placed. Obviously tension force is going to be acting, because of tension force tensile stresses are induced. Now finally we need to find the reactions. That reactions is equal to RQ. That reaction, what is that reaction? R is equal to KQ minus F. Therefore R is nothing but R1, R2, R3. That is equal to this much. K is this much, Q is Q1, Q2, Q3, F Substitute the values of q1, q2, q3, and f is this much. I think it is not so yeah, this is not 100, this is 1000.1. Okay, this also become, therefore finally we got reaction R1 is 1000.568 and R2 is 0 and R3 is 0. So only reactions induced at the fixed support. Now we will validate this result. How to validate? You see the global force vector, you add it 1000.413 plus 0.241 plus 0.1723, you will get the same value of this approximately. Therefore this is plus, that means it is acting downward, minus means opposite reaction. So applied force equal to reaction force, then your problem is correct. So this completes this problem. This is one of the important problem as per the VT question paper.